Two resistances are connected parallel to each other. There you have in Wheatstone bridge you have three fixed resistances, and one is unknown resistances. So in that three fixed resistances, one is variable resistance. So we can vary that resistance. By varying that resistance, we can make the galvanometer current as zero. That is in null position. We can say that bridge is said to be in balanced condition. There, based on that balanced condition, R2 by R4 equal to R3, R1 by R3, you can find out the unknown resistance. So there, that is Wheatstone bridge. Now today I will explain you about the Kelvin's bridge or a Thomson's bridge. So Kelvin bridge is a modification version of Wheatstone bridge. So so in order to find out the resistance of lead resistance or contact resistance are very low resistances. In order to find out the low resistance, we are using the Kelvin bridge. So we can measure the resistor, means the range of the resistance by using Kelvin bridge are from 1 ohm to approximately 1 micro ohm. So it can be used to measure, so whereas the Wheatstone bridge is used to measure the resistance from few ohms to several kilo ohms. So this Kelvin bridge is mainly used to measure the low amount of resistance, either from 0.001 to 1 ohm, 1 ohm, and the range of resistance. So it is mainly used to find out the lead resistances or contact resistances. So, but error occurs in result when it is used to measure the. So when you are using, when you use this Wheatstone bridge to measure the low resistances, you can get the errors. Okay. So in order to modify, that means modification of Wheatstone bridge is nothing but the Kelvin bridge. So this Kelvin bridge is mainly suitable for the for calculating the low resistances. So this is the Kelvin bridge, or we can call as Thomson bridge. So you have three fixed resistances, and one is unknown resistance, and these are the leads. So there is one lead resistance, Ry will be there, and the supply voltage is there. Supply voltage is given to 2 ohms, and there is a galvanometer. So galvanometer will gives a if there is any unbalanced condition, it gives some reading. So when it is giving some reading, we can say that the bridge is said to be unbalanced. So we should make the bridge into balanced condition in order to find out the unknown resistance. So here if you see, when the galvanometer is connected to point A, the lead resistance Ry is added to the standard resistance R3. So that means, so when this galvanometer is there, no? When it is connected to A, so anyway, Rx is having some amount of resistance. So along with the Rx, Ry will be added. So that means that the resistance will increases. And next, so
yes, some students are waiting at the room.
Okay, 1 second. Okay, is it okay? Admitted. Okay. When it is connected to point C, so what happens? Uh, so when it is connected to point C, Ry is added to Rx. So when it is connected to point C, what happens? So when it is connected to point A, galvanometer pointer is connected to point A. Ry is connected. Ry is in series with Rx. That means you will getting the unknown resistance as large amount of resistance. When the galvanometer pointer is connected to point C, what happens? This Ry is added with R3, and the unknown resistance Rx will decrease. So see here. So here. So when it is connected to point C, so that means when it is connected to point A, this Kelvin bridge can measure a large amount of resistance. In order to find out a small amount of resistance, the galvanometer pointer is connected to point C so that the resistance or no resistance can decrease. So you can find out small amount of resistance. This resistance will be added to this fixed resistance R3 plus RY. So instead of connecting this galvanometer point to either point A or point C, uh, the galvanometer pointer is connected to exactly between this A and C, that is connected to point B. See here. Instead of connecting the galvanometer to point A or point C, we can say some intermediate point, that is say point B. Here, when you are connecting this to the point B, so whatever the lead resistance or a contact resistance is divided into two equal parts. So that means when it is connected to uh, so point B, so the lead resistance will be exactly divided into two equal parts. That means Ry by 2, and here also you are getting Ry by 2. So it is divided into two equal parts. So now we will see. So when the bridge is in balanced condition, we have to measure the unknown resistance, that is Rx. So when bridge is balanced, when it is connected to point B, you can say that RCB by RAB equal to R1 by R2. So here, if you see RCB by RAB equal to R1 by R2. So this is the condition when the bridge is said to be in balanced. That means you are getting the current across the galvanometer as 0. So when your galvanometer current is 0, you are getting this relation. That means RAB by RBC equal to R1 by R2. So see this, RCB by RAB equal to R1 by R2. This is usual balance equation for the bridge. Mm, next, Rx plus RCB. So if you see this one, Rx plus RCB, you can write as R1 by R2, R3 plus RAB. R1 by R2 into, so Rx plus RCB, Rx plus RCB equal to R1 by R2 into uh, this one R3 plus RE. So when it is connected to the position B, you can write this like this. So Rx plus RCB equal to R1 by R2 into R3 plus RAB. So 1 second, some are waiting. Okay, but we know that the RAB plus RCB equal to what? RY. So if you see the diagram, the lead resistance RAB plus RCB equal to what? RY. And next RCB by RAB equal to what? R1 by R2. So this is from equation 1. So you got this relation. Now RCB by RAB, you have to add both sides with 1. So RCB by RAB plus 1 equal to R1 by R2 plus 1. So here, uh, so take LCM, RCB plus RAB by RAB equal to R1 plus R2 by R2. But RCB plus RAB is how much? RCB plus RAB equal to RY. So RY by RAB equal to R1 plus R2 by R2. So from here, RAB equal to what? R2 into RY by R1 plus R2. Where RY equal to what? RAB plus RCB. So this is the lead resistance in terms of RAB resistance in terms of R2, RY, R2 and RY. So this is the expression for RAB. Okay, and next you know that RCB equal to what? So RCB you can write as, see here, RCB equal to the total lead resistance. So what is the total lead resistance? RY minus RAB. Can you write this one? So like this you can write. So if you see RCB equal to RY minus RAB, RY minus what is RAB value? this value substitute in this above equation. R2 into Ry divided by R1 plus R2. Now take LCM R1 Ry plus R2 Ry minus R2 Ry divided by R1 plus R2. So R2 Ry get cancelled. So what is remaining? RCB equal to R1 Ry divided by R1 plus R2. So this is the expression for RCB. Now substitute the value of RAB and RCB in equation 2. So what is our equation 2? This equation. Substitute in this equation. So which value? The value of RCB and the value of RAB. So in this equation, if you substitute Rx plus what is RCB? RCB equal to R1 Ry by R1 plus R2. No? Rx plus R1 Ry by R1 plus R2 equal to R1 by R2 into R3 plus RAB. So what is RAB value? R2 into Ry by R1 plus R2. R2 into Ry by R1 plus R2. And now you can multiply this one. R1 R3 divided by R2 plus R1 R2 Ry divided by R2 into R1 plus R2. Now so here R2 get cancelled. Anyway, R1 Ry divided by R1 plus R2, R1 Ry divided by R1 plus R2, both are same, no? So this can cancel each other. So what is remaining? Rx equal to R1 R3 by R2. So you got the same relation, no? So that means Rx equal to R1 R3 by R2 means it is nowhere depending on the unknown resistance is nowhere depending on the late resistance, that is R1. See here. This whatever the equation you got, this is the usual equation we got in the Wheatstone bridge. So the equation is usual Wheatstone bridge balance equation. So this indicates that resistance of connecting leads from point A to C has eliminated by connecting the galvanometer to intermediate position. So when you connect this galvanometer to intermediate position, so whatever the resistance is there, so Ry is the lead resistance that is connected, that will be eliminated. Okay, that will be eliminated. So that is not depend. Rx you are getting in terms of R1, R3 and R2. Okay. So this is basic derivation of the Kelvin or Thomson bridge. Next is Kelvin's doubles bridge. Double bridge means between this Ry there are two resistance will be added. So A and B will be added. So this resistance A and this resistance B. So this above principle is a basic Kelvin's double bridge. Why this is Kelvin's double bridge? A second set of ratios are say ratio arms are added. So what are the second sets of ratios? The resistance A and B is added to the Kelvin's double bridge. That's why we call it a Kelvin's double bridge. So if you see, second set of arms A and B connects the galvanometer to the point C at appropriate potential between M and N connection. Ry is the ratio of the arms A and B in the same ratio R or R2. So that means here second set of arms B and A, the resistance B and the resistance A is connected to points M and N. These points the resistance is connected. So if you see, so when the galvanometer is giving some indication, so you can say that when the bridge is in balanced condition, so when a galvanometer indication is 0, when the potential at K and C are equal. So see here, the galvanometer current is 0 or bridge is said to be in balanced condition when the potential at K. So here potential at K, this potential and potential at C are equal. So this potential and this potential are equal. So that means potential at K, let us consider EKL. Potential at K is EKL. And next potential at this C is nothing but So what is that? ELMC. So you can write that ELMC. Potential at C is nothing but ELMC. So this potential equal to this potential. So ELK equal to ELMC. But what is ELK? ELK equal to, by using the voltage division, you can find out ELK. ELK equal to what? The total voltage into this branch resistance by total resistance. So what you are getting? ELK equal to the total voltage. So what is the total voltage you are applying? E into R2 by R1 plus R2. So by using voltage division principle, you got the potential across the ELK. Next, you have to find out E. E equal to I into R3 plus RX, R3 plus RX plus A plus B into RY by A plus B plus R1. So total current into R3. So where is R3? R3 plus RX. Can you able to listen my voice, students?
Yes, sir.
So this is Kelvin double bridge. This is EL. You got ELK equal to ELMC. ELK equal to this. So if you want to find out this branch voltage, ELK equal to total voltage into this branch resistance by total resistance. So that means by using voltage division principle, I calculated ELK. Now total voltage E equal to what? Total current. So whatever the current is flowing through this bridge into R3 plus RX plus A plus B into RY divided by A plus B plus RY. Now you substitute this E equation in this above equation. This E equation in the above equation. So what you are getting? ELK equal to R2 by R1 plus R2 into I R3 plus Rx plus A plus B into Ry divided by A plus B plus Ry. Similarly, you have to find out ELMC. So this ELMC you have to find out. So I into ELMC. So ELMC, if you want to find out I into R3. So I into R3 plus B by A plus B, A plus B into Ry by A plus B plus Ry. So this is the expression for ELMC. But we know that the potential at K equal to potential at C, no? So ELK equal to ELMC. Substitute this one. So IR2 divided by R1 plus R2 into R3 plus RX plus A plus B. This equation 2, that is nothing but ELK. Okay. And next ELMC is nothing but this one. So this one. So I into R3 plus B by A plus B into A plus B into Ry by A plus B plus R1. Now, so here anyway the current I and IA get cancelled. Okay. So next 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 R3 plus, so this one you bring it to this side. That means here R2 by R1 plus R2 is there, no? So when it is going to this side means it becomes reciprocal. That is R1 plus R2 by R2, no? See here R3 plus Rx plus A plus B into Ry divided by A plus B plus Ry, that is equal to, so this is going into RHS, becomes R1 plus R2 divided by R2 into the same thing R3 plus So R3 plus, so if you simplify this one, so you are getting this one. So B into Ry by A plus B plus Ry. Now divide this one. So R1 by R2, R2 by R2. So both get cancelled. You are getting 1 plus 1. Next, Rx plus A plus B into Ry divided by A plus B plus Ry plus R3 equal to, you multiply this one. So R1 R3 by R2 plus R3 plus B R1 Ry by R2 into A plus B plus C. So multiply this one and next this one and next this one. So B into R1 Ry by R2 into Ry plus B into Ry by A plus B plus Ry. So here, so what you are getting? Mm, Now you have to, so anyway R3 get cancelled. So you have to find out Rx equal to R1 R3 by R2 plus B into R1 Ry by R2 into A plus B plus Ry, this one, and B into Ry by A plus B plus Ry. So this one will come to this side, becomes plus becomes minus A plus B into Ry divided by A plus B plus R. Now what you should do? Anyway, B into R1 Ry by R2 into A plus B plus Ry is same thing. So you have to take LCM. So these both are same. No, you can take LCM. LCM is A plus B plus Ry. So B into Ry multiply minus A into Ry minus B into Ry. So here B into Ry, B into Ry get cancelled. So what you are getting? R1 R3 by R2 plus B R1 Ry by R2 into A plus B plus Ry minus A Ry by A plus B plus Ry. Now you can take B Ry by A plus B plus Ry common. So what you are getting? R1 by R2 minus A by B. But we know that R1 by R2 equal to what? A by B. So that means, so when both are equal, this becomes what? 0. So that means what you are getting? In the double bridge also, you are getting Rx equal to what? R1 R3 by R2. So in the previous condition, you got the same relation. In the double bridge also, you got the same relation. So Rx equal to what? R1 R3 by R2. So this is a usual equation for the Kelvin bridge. So whatever the usual this equation is there, this is the usual equation for the Kelvin bridge. So the above equation indicates that the connection leads. So whatever the connection, initially we have seen the connection leads are, simply it is Ry. The galvanometer pointer is connected to either A or C. So when it is connected to B, we realized that during calculating the unknown resistance Rx, there is no effect of those lead resistance. The Kelvin double bridge, what we have done, we added two more resistors A and B, and we calculated. There also in Kelvin double bridge we got Rx as uh, this equation, Rx as R1 R3 by R2. Here also there is no effect on the Ry. So Ry has no effect of measurement. The ratio is same, you are getting the unknown resistance you are getting in terms of R1, R2 and R3. So, where we use this Kelvin bridge in order to find out a low amount of resistance like lead resistance or contact resistances, we can use this Kelvin bridge. So it can cover up to 1 to 0.0001 ohms or 1 to 10 micro ohms. So this is the accuracy. So accuracy is 0.052 plus or minus 0.2%. So this is the accuracy of a Kelvin bridge. So in order to, you have to remember, that means Wheatstone bridge is used to measure the high amount of resistance in terms of like kilo ohms or mega ohms. We will use Wheatstone bridge. Kelvin bridge is used to measure the low amount of resistances. So let's when you want to find a lead resistances or contract resistances, those resistances are very less. So in that situation, you will use this Kelvin bridge. So this is one problem. he given that the ratio of Ra to Rb is 1000 and R1 is 5 ohms and R1 equal to 0.5 R2. So what is the value of Rx? So you have to find out the unknown resistance Rx. So you can say that Rx by R2 equal to Rb by Ra. So resistance of Rx can be calculated by using this relation. So Rx by R2 equal to, so Rx by R2 equal to Rb by Rb by Ra. So Rx by Rt equal to Rb by Ra. So what is the ratio? Ra by Rb is given as 1000. So what is Rb by Ra? Just reciprocal. So that means you are getting 1 by 1000. So 1 by 1000. But what is R1? Given R1 equal to 0.5 R2. From here you can find out simply R2. R2 equal to what is R1? R1 is 5 ohms. So that means 5 by 0.5 you are getting R2 as 10 ohms. So Rx by 10 equal to 1 by 1000. Reciprocal Rx equal to 10 into 1 by 1000. So 1 0 cancel. So what you are getting 1 by 1000. So Rx equal to what? 0.01. So like this you can find out the resistance of unknown R. Okay. So this is about the Kelvin bridge. So the Kelvin bridge is mainly used to find out the resistance of lead contacts. Okay. Lead resistances or contact resistances. We can find out this amount of resistance.